Hi, Earth Science peeps. This is Mrs. Color talking about the Blizzard of 96 handout because I know part of it came out blurry for you guys, so I'm going to go over it with you, okay? So I want you to check your answers as we go, okay? So obviously this is just showing you a map of the Blizzard of 96 and where all it hit and how many inches of snow, which is an insane amount, of course, which is why we study it, okay? This is the map that I understand is hard to read, and it's clear on my end, but it is jumbled up together, which is very difficult. So I do think it's very important for you to know the station model and how this works. So if you have any questions about that, just let me know. It's pretty straightforward as far as where this is coming out, is where the wind speed is coming from. So that is an important part, is talking about the wind direction. So in this case, it would be southwest. Okay, so make sure you pay attention to that. So you do need to be able to read those. Okay. All right, so let's talk about, I numbered the questions. I know they're not numbered on your paper, but I numbered them, and you should number through 28, okay? So number 1, using the station model guide, what's the air temperature in degrees Fahrenheit in Richmond, Virginia at the same time of the surface weather map? And the answer is 22. Okay, so I'll just show you where I've highlighted the answers. Number 2 is New Jersey. Number 3 is 984. That's the surface pressure. The shaded area most likely represents precipitation in any form. In this case, guessed it's snow. The precipitation falling is frozen. Okay. New York City is reporting an air temperature, I know this is hard to read, but it is 19 degrees Fahrenheit, and a dew point temperature of 17 degrees. And this is indicated by humid air, so a lot of water vapor in the air, and this is consistent with the precipitation depiction of the map. The snow shield of the nor'easter is most concentrated and intense on the northwest side of the storm. And then I want you to, if you look at the high pressure over here in Canada, that's Canada, and there's the high pressure. The pressure system is responsible for cold and clear weather conditions in Canada. Based on the surface temperatures in Canada, that is most likely Arctic, okay? And you should have those, that on a separate map, the Arctic and the polar and all of that, and we'll talk about that later. Using the wind barbs as an indicator, air circulates counterclockwise around a nor'easter, which is a low pressure system, so that's important. Counterclockwise and low pressure system. In contrast, it's clockwise with a high pressure system. So definitely number 9 is extremely important, okay? Number 10 is Nantucket. Number 11, airflow off the Atlantic. Number 12, a changeover from sleet and or rain is common when the wind direction is off the ocean when it's not frozen. What is the reported wind direction in Albany? North. Number 14 is 14. That indicates dry air for number 15. Number 16, the Canadian Arctic high pressure is responsible for the air mass. Number 17 is heavy snow, obviously. Number 18, farther away. Number 19, this is because of an increase in 2 millibars over the past 3 hours. And the millibars are just the little lines on the map, okay? Number 20, the station is located near Virginia. The air temperature at the station is 52, and southwest wind direction bringing in mild maritime air mass, which maritime means it's coming from the water. Okay, so these maps, I hope they came through okay for you to look at. Okay, number 22, accumulated snowfall. 23, Miller A. I will not test you on this, okay? Miller A and Miller B will not be on your test. According to the storm track diagram, the state that's completely covered in snow is definitely concentrated over Pennsylvania, okay? The number 25, the surface low pressure originated in the Gulf of Mexico. The surface low pressure tracked in general northeast direction. Number 27, low pressure remained over water. This allowed for the cold air mass to stay entrenched over water. That's important for sure. A surface low pressure track further to the west would have resulted in less snow over the area due to an influx of warmer air, primarily because of a change in wind direction. That which controls most things are the wind. Okay, so go over yours and check your answers, and I hope that this helped.